Hey everyone, and welcome to video 4 of week 2. And in this video, we're going to talk about the fourth step in our 6-step series to designing data structures and databases, and that is identifying primary keys and foreign keys. And so if we jump into our previous example, so if we recall, we've gone ahead and broken our data elements into tables. And so now we need to identify our primary keys and foreign keys. And so if we work through each table, we're able to identify, well, we can start by identifying the primary keys for each table. And so in our customer table, we're probably going to have a column called ID, which is going to be an integer, not null, which is going to be an identity column, auto-incrementing. So we're going to add an ID column to the customer table, and this is going to be our customer ID. And that column is going to be an integer, it's going to be not nullable, it's going to be an identity column, and it's going to be auto-incrementing, meaning that for every customer we add, that customer is going to get an auto-incremented ID. And so actually for most of these tables we can do the same. So in vehicles we'll add a vehicle ID, we'll add an ID to parts, we'll add an ID for work orders, which will actually go ahead and replace the work order number. And one thing I want to circle back to on parts is that you notice that we kept the part number but not the part ID. So the part number is going to be the part number specific from the manufacturer, whereas our ID is an ID for, and actually we can go ahead and keep, we'll go ahead and keep that. So, and then our ID is going to be our part ID in our system. The same thing with the work orders. So our ID is going to be separate from our work order number. So let's say that our work order number is coming from a separate system. Or maybe a separate software that's being passed in. And the same thing with our employees, right? So our employees are going to get an ID that's going to be not null. It's going to be an identity column, it's going to be auto-incrementing. So that's the first part, is to identify the primary keys in the table. Now the second part is going to be identifying the foreign keys in each one of these tables. And so on the customer table, if we think about what relationship customers have to other tables, really, there's only going to be one foreign key, and that's going to be to vehicles. And so what is the relationship that a customer would have to the vehicles table? Well, a customer can have many vehicles. A customer can have a vehicle, or a customer can have multiple vehicles. And so to do that, we need a linking table. We need a linking table to join customers to vehicles. So We'll call that customer vehicles. And that's going to, this particular table is just going to have customer ID, int not null, foreign key. I'm kind of just winging the notation here. Foreign key to customers. Then we're going to have vehicle ID int not null, foreign key to vehicles. And so what about our vehicles table? Are there any foreign keys that we for tables? So not necessarily, but if we look at our parts table could in theory map to could potentially have a relationship to our vehicles table. So for simplicity's sake, let's ignore that potential relationship and assume that our parts are being stored for let's assume that our parts are being our part information is being given to us from a different software. So let's assume that our parts table is used for inventory purposes and our vehicles table is used for customer purposes. So on our work orders table, we're actually going to have several different foreign key relationships. And so the first one, whoops, I don't know why that jumped back. Vehicle. So on our work orders, we're gonna want to add a column for vehicle ID, and not null, foreign key to vehicles, and that's basically each work order is going to be reflective of the vehicle that the work order is for. Now, what about parts? So obviously a work order is going to include a list of parts. So in that case, we want another linking table, which is going to link work orders to parts. And just like above, we're just going to have part ID and work order ID. And so this is going to create our relationship between work orders and this is going to create our relationship between work orders and parts. So what other tables could we potentially have a relationship from work orders to? Well, we're probably going to have a relationship between employees and the work order. So which employee worked on a specific work order, and for that we'll call that foreign key employee ID int not null, foreign key to employees. And so there's probably another table that we can create from all of this, and that's going to be our actual invoice table. And so that's going to store all of our relationships between these tables in one single table. And so we're going to create another table, invoices table, invoices, and that's going to have obviously an ID, which is going to be whoa, I screwed that up. Int not null, fk to parts, int not null, fk work